Hi guys, welcome back to another video. Today I'm gonna show you how to do a proof by contrapositive. So let's start with the definition. What is proof by contrapositive? So a proof by contrapositive proves a conditional term of the form P then Q by showing that the contrapositive non-Q then non-P is true. So to prove P then Q, you just need to prove the negation of non-Q then non-P. So let's look at the example, the following example. So prove that for every integer n, if n squared is even, then n is even. So let's express this example in terms of P and Q. So P represents n squared is even and Q represents n is even. So to prove P then Q, we just need to prove non-Q then non-P is true. And what is non-Q? Non-Q, n is odd, and non-P, n squared is odd. So let's start our proof. N is odd, then n can be expressed as 2q plus 1, 2k plus 1 for some integer k. And n squared, it's equal to 2k plus 1 squared. And we distribute that, you get 4k squared plus 4k plus 1. And we can factor out by 2. And we get 2 times 2k squared plus 2k plus 1. And now, since 2k squared and 2k are integers, are both integers because k is an integer and 2 is an integer, so you multiply two integers, you get another integer. And we can replace 2k squared plus 2k with another integer L. So now n squared can be expressed as 2L plus 1 for some integer L. And that's the definition of odd numbers. So by definition, n squared is also odd. So now we prove that if n squared is even, then n is also even. Let's look at another example. So another example, prove that for every positive real number x, if x is irrational, then the square root of x is irrational. So again, P represents x is irrational, and Q represent the square root of x is irrational. So let's prove this question by contrapositive. So that means we need to prove non-Q, then non-P is true. So suppose the square root of x is irrational. So that means there exist two integers, a and b, such that square root of x can be expressed as a over b. And b it's not equal to 0, of course, because it is in the denominator. So now if we square square root of x, we get x, which equals to a squared over b squared. Now, since a and b are integers, then a squared and b squared are also an integers. And since b is not equal to 0, then b squared it's also not equal to 0. Now we express x as a squared over b squared, where a squared and b squared are both integers. And therefore x is a rational number. So I hope these two examples help you understand the proof by contrapositive. So thank you for watching and see you next time.